Thank you very much for joining me on this talk, IoT DevFest 2017, Smart Cities Enabling a New Social Fabric with Fog Computing. I've got a couple of videos to share with you all, which hopefully you'll find exciting. And what I'm going to do is give a background about smart cities and why they're important, explain a little bit about some of the smart city initiatives that are going on around the world, explain to you why open fog is so important in enabling us to innovate a new type of smart social fabrics for smart cities, meeting the challenges we're going to be facing in the future. And also share with you about some best practices and some of the initiatives that are happening around smart cities, in particular in Colorado, where I'm involved. Okay, so let's remind ourselves that societies will face some severe pressure, both globally and locally, in the forthcoming 20 to 30 years. And we're all probably aware of this figure of another 2.4 billion people joining the planet by 2050. And that's going to put a huge pressure on cities and towns and locales. The United Nations reckon by about 2050 there'll be an additional 3 billion people living in and around city and their suburbs. And just imagine that mass increase of people around cities demanding that require water, energy, road infrastructure, housing, healthcare, jobs, and many other things as well, education and schools. So we have some big pressures that are going to be facing society as we increase our population. And McKinsey talk about the world's population are going to be moving to cities due to economic and climate reasons. And I'm sure you're all aware of that climate change is a real threat at the moment to planet security. So with all these billions of people that's going to be moving in and around cities, it's really important that we build intelligence-driven city services and infrastructure to equip locales to innovate and resolve the increasing pressures they face from population growth, human activities, and limited resources. And I believe this is the purpose of the Internet of Things, is to enable smart cities and to enable us to build new smart social fabrics and economies. So you're all probably aware that the Internet of Things global market sizes are really quite enormous. And these are some of the figures from McKinsey. Smart cities, about $1.7 trillion USD. You're all probably aware that food security is an enormous challenge. We need to increase our food output by 70% by 2050 if there will be 9.6 billion people on the planet. And that's a huge challenge for our global society. So smart farming and smart agriculture is something that's very much on the Internet of Things radar. And things like the industrial Internet of Things, leveraging machines and robotics and robots themselves to optimize our creation of products and our distribution chains. Logistics are also another big market for the Internet of Things. And you're all probably aware around healthcare that bringing healthcare to the home with smart home and smart healthcare in the home is something that is being explored a lot at the moment. And basically our hospitals were designed for acute conditions like having a baby or maybe in a car accident. But when it comes to long-term healthcare, the hospitals weren't really designed for that. And so moving long-term healthcare to the home makes really good sense. And, things like telehealthcare with video streaming to doctors is very important. And also things like monitoring our heart and our diabetes automatically and conditions within the home is something that is very imperative and actually is cost effective. And GE talk about $60 trillion US to be invested in the Internet of Things in the next 15 years. And that's a huge amount of money. And it's bigger than some economies in their GDP. So the Internet of Things is really an enormous market for investment, for innovation, with plenty and plenty of market verticals available for innovation, ROI, and delivering smart services. And you're all probably aware that, for smart cities, it's about IoT sensors gathering data in real time throughout the city. So sensors could be on things like street poles, or it could be assets like street lights, on people, in the environment. You probably saw yesterday on the BBC that Delhi had such awful smog conditions. It was 30 times higher than the safety level from the World Health Organization. And so air quality is something that's a real challenge, particularly in Asia and other areas like that. Things like infrastructure, smart transport. We all know that congestion is getting worse and worse in some of the cities. And so actually leveraging IoT to actually optimize traffic congestion, get people into public transport is something that's been explored a lot. And also smart buildings as well. And so all that data from around the city is sent to kind of a city brain, computing intelligence platform that has things like big data and other technologies like artificial intelligence and machine learning. And all this data from the physical world, these huge tranches of data, are stored, and then information is created. And from that information, we can actually create meaning. And that meaning can then be leveraged by applications to take intelligent action in the real world. And so Internet of Things in smart cities is really, really an imperative innovation for our future to provide citizens with efficient, safer, and a smarter lifestyle so that we can all integrate together sensibly and everybody thrives. And so this diagram basically shows that sensors within a city could be deployed within a factory, within a city, within a hospital, on a grid, and smart grids, another big vertical. And I'll get up to energy resilience a little bit later. And basically across any aspect of the city, particularly transport infrastructure, where we can actually start monitoring what's going on in real time and then taking intelligent action. And so from Milton Keynes, United Kingdom, just these are some of the kind of applications that they've been looking at for a while. And these are very common throughout smart city initiatives in the world, looking at things like waste management and optimizing logistics, particularly energy and water metering to provide fair pricing to the end user. Things like smart parking. I'm sure we've all had problems in finding parking when we've tried to go to the city for a meeting or out with our girlfriends for the evening. Things like agriculture, as I talked about. Milton Keynes is very interesting because it's a city that's surrounded by agricultural land. They decided to extend their smart city initiative outside the city to include agriculture. And local agriculture, rather than big agriculture, is going to become more and more of a phenomenon in and around cities. Things like street lighting, to optimize the amount of lighting that we're using during certain times of the day, and to reduce it when there's no one around. And also street lights are a very useful asset for deploying things like small cells, low power wide area networks, things like fog computing. Basically, these are assets in which we can deploy infrastructure to measure more information from the physical environment. So I want to introduce you to fog computing. And this is what we call this extending the cloud to the things continuum. And I have a little video which I think is very useful in actually explaining what fog computing is. So just bear with me while I play this video.
In a world filled with digital innovation, technologies including the Internet of Things, 5G wireless networking, and even embedded AI continue to further the pace of change. And with these technologies, billions of new apps and devices are coming online, working to measure, monitor, process, analyze, and react to a seemingly endless storm of data. Not that long ago, all of this data was handled by the cloud alone. But now, this veritable storm is too much even for the power of the cloud, and the need for a new approach is clear. For an architecture built to resolve latency, network inaccessibility, rising costs, and sensitive data security concerns. That's where fog comes in. Fog computing is a new distributed architecture, one that spans the continuum between the cloud and everything else. This allows for the distribution of critical core functions, compute, communication, control, storage, and decision-making, closer to where data is originated. That's what makes fog not just a common sense architecture. It's a necessary, vital architecture for scenarios where latency, privacy, and other data-intensive issues are creating cause for concern. And at the Open Fog Consortium, we're creating the open, interoperable architecture necessary for making fog work across operational silos, across industries, across suppliers. Our members from around the world are collaborating even now on use cases, test beds, technical specifications, and an open interoperable reference architecture built for today's connected world. We are the Open Fog Consortium. Join us as we enable and accelerate the coming era of fog computing.
So thank you for watching that video. I hope it was instructive. It's really quite incredible, isn't it? It's actually bringing the power of the cloud right to the edge of the network. And I'm going to explain a little bit more about that. One of the roles that I have is a global ambassadorial role for the Open Fog Consortium. And you can find a lot more information at this URL at the bottom of the video. You can look at use cases and reference architectures as well. So it's a great source of finding out more. And I've also got a channel as well. So when you click on that link, there's for the YouTube video I've just shown, it's from the TV channel for Open Fog, and there's a lot more information in there. Okay, let's get back to the presentation, shall we? So as you've just seen in the video, it's about extending the cloud to the things. It's about bringing cloud computing right to the edge of the network. And I'm going to explain why that's so important. But basically, imagine a cloud deployed across the edge of a city within less than a mile of any sensor. And it's a system-level horizontal architecture that distributes powerful computing, automation, i.e. artificial intelligence, decision-making, storage and networking much closer to the users. And this is one of the fundamental requirements for seeing out of smart cities is something called resilience. And part of the definition of resilience is that a city must be able to exist for 72 hours, or maybe a little bit less, without being connected to the outside world. So if you have a cloud server, or your cloud for your city, that is outside your city, and maybe a disaster happens, then effectively you've lost all your automation. And so bringing the automation, the powerful computing, the artificial intelligence, the decision-making, the real-time services right to the edge of a city and across a horizontal infrastructure meets that requirement. And this is becoming more and more predominant as the best practice throughout smart cities. And so what you get are things like moving the cloud to the edge of the network, optimized data-driven smart services. It also deals with security and resilience. Resilience I've always touched on, but because data may not ever get to the cloud, because data may stay across the horizontal architecture, then there's less ICT infrastructure and platforms for it to go through if it was in the cloud. And so actually it reduces the risk of cybersecurity threat, which is quite a positive thing. And obviously we can have optimized automation and performance of applications right at the edge. And what we can do, because this is a horizontal infrastructure, we can actually start integrating applications together in order to make more of a holistic decision. And I'll talk a little bit more about a use case in a little while. So Open Fog talks about scale, which is about security, cognition, agility, latency, and efficiency. And really, this is very simple. This is about bringing efficiency to AI, IoT applications right at the edge of a city, and actually doing all the hard work right at the edge of the city, rather than actually it being in a remote cloud platform somewhere outside the city boundaries. And you may well have heard of edge computing. And edge computing is a big phenomenon. But basically, if you look on the left, it's really quite a siloed approach. So, smart transportation, for example, on the left-hand side in blue, basically that kind of indicates it's really quite siloed, as with all the other type of edge services. And they're not communicating together. They're not actually leveraging assets throughout the city to actually run their service. And so if you look to the diagram on the right with fog nodes, this shows more of an integrated type of edge computing, where the edge is integrated horizontally, where data can be shared, where processing resources can be obtained and shared, where security can be at its very top level. And so this has a lot of advantages to be able to integrate across the edge horizontally, across many, many services that actually will become interconnected at some stage. And this is why standards are so important, and I'll get onto standards in a little while. But hopefully you can start to see the difference between edge and fog. Edge is very siloed. Fog is about integrated computing, horizontally integrated processing, integrated decision making, right at the edge of the network. And so fog computing could well be the next TCP/IP. TCP/IP is a standard universal framework for packet distribution. Tim Berners-Lee invented the World Wide Web, which is a standard universal framework to access files and websites anywhere. And the Open Fog Consortium believes that fog computing is the next standard and universal framework for distributed computing resources and services horizontally across a city. And standards are very, very, very important. They've been proven to develop the markets. And so it's very, very important that we actually work together to actually define these new types of open fog standards, communication protocols, security protocols, pool management, computing management, all those kind of things. And you can see more in the reference framework on the website. And so here's the Open Fog Consortium. It's founded by Intel, which I'm sure you'll all be pleased about. But also Cisco, Dell, Microsoft, and Princeton University are also founders of this consortium. It was launched in 2015, and it's really growing, actually. And this is a flavor of the types of members that are involved in the Open Fog. And it's global reaching, right? So there's 16 countries so far involved in Open Fog computing, all recognizing that distributed computing right at the edge is fundamental to enable many, many, many markets, of which smart city is one, industrial Internet of Things is another. And so, as you can see, there's just plenty of organizations, and there's universities involved, such as Princeton and the Colorado University of Colorado. There's small, medium enterprises involved. There's large F50 and F100 companies involved. And there's also, and they're all active in different parts of the tech stack. And that's really quite exciting because we're drawing on a wealth of information and expertise in order to have a comprehensive solution. So what are the advantages of Open Fog in city smart use cases? Let's just go through a few smart city use cases. And you can find out more information from the Open Fog Consortium. I'm always mindful of the great instruction from that incredible individual called Einstein. And he said, we cannot solve the problems that we face today with the same thinking that created those problems. And this really is about a new innovation mindset. It's about a new collaboration mindset. It's about a new form of leadership where we kind of imagine and build a very different world. And so if we have things like IoT deployed, 5th generation, new types of cybersecurity and better resilience and security, and machine learning, i.e. this is what Open Fog provides at the edge of the city, then it has many benefits. I've already talked about the fact that it's a horizontal ICT infrastructure, and that provides a resilient smart city platform. Remember I mentioned earlier that some of the requirements of smart cities are about resilience, where your city ICT infrastructure can exist for maybe a day or two, maybe longer, without communicating with the outside world. And it also delivers something called a high quality of service right at the edge, high compute intelligence and performance, and then we can optimize some of the key smart city services now and in the future. So let's look at some examples. I'll come back to blockchain. So I've mentioned smart healthcare, and that's really quite interesting. But obviously, with transportation we've been seeing for a long time innovation around automated vehicles, and this is ramping up significantly. And so having high performance computing, high performance analysis, high performance applications right at the edge of the network is imperative if these cars are to communicate with the edge of the network, maybe to infrastructure, maybe to other cars, maybe to a robot or something like that on the sideline, on the sidewalk. So it's very important that we have this open fog deployed in cities in order to enable automated vehicles. We simply can't trust that a satellite connection will be performant enough for a vehicle. We simply can't believe and trust that actually going all the way back to the cloud will give us the response time that we actually need in certain conditions. So that's a very important application for open fog. And other use cases like disasters, you know, if there's a disaster on a freeway, then kind of all hell breaks loose, which is horrible. And so the effects of an accident not just are in the immediate vicinity, but also affect all the other transportation feeds into that locality. And so actually be able to distribute decision-making and computing to reroute maybe traffic, to be able to move traffic to a particular lane in order for the emergency vehicles to get through quicker, maybe with street lights guiding them on the fastest route, is really quite important here. And at the moment, emergency services, a lot of innovation around this. You probably would have seen the first net announcement with AT&T. There actually is a lot of investment around this. And it's very, very, very man-driven. It's very, requires a lot of man effort or person effort. And so if we can have automation at the right at the edge of the network to detect a disaster scenario, to be able to build kind of a machine to actually manage everything very, very quickly at the edge of the network and scheduling assets and resources to come and resolve the problem very quickly, then that has a lot of advantages in terms of speed of response and maybe even save lives. Obviously drones, which are a very, very exciting kind of innovation, kind of fun innovation. And we've seen a lot of movement around these kind of services like drones, with policy changes around flight rights over particular territories and things like that. And so for drones, you know, assuming that this is going to take off, and I hope it does, because it sounds quite fun, then they're going to need high power computing right at the edge. They're going to need decision-making right at the edge. And so in order to enable drones, then I think that we need this high-performance computing right at the edge and across the whole city, because drones will be going across the city. And there's a super use case on the Open Fog Consortium website around this. Obviously, smart buildings, you know, we're starting to see a lot more face recognition. We've seen the Phone X come out, which is basically your face that is recognized as the unique identifier to access the phone's rights, you know, your kind of genetic footprint, your genetic identifier. And I think in smart buildings, we're going to see a lot more video requirements, a lot more analytics around video. And so having that right at the front of a network around a building is a big enabler for open fog, and open fog can certainly enable these types of use cases. And so I think we'll see smart buildings become very popular for these powerful open fog ICT infrastructures deployed throughout the building for all types of services, anything from CO2 monitoring through to rights access, identity management, and video. And of course, that brings me on to public safety, which is very high in many city agendas, in many regional agendas. And so we're capturing all this information, this video information, right at the edge of the network. And actually, we want to process it faster. We want to process and make decisions much quicker. And so having processing right at the edge of the network through an open fog ICT infrastructure, then effectively we can start making decisions much quicker. We can start detecting public events much faster that may be disasters, or maybe there's been a crime, or maybe there is an event that needs responding to, such as a car accident. Because we're going to have a lot more video and analytics right at the edge, then having high power computing is going to make quite a difference. And so I want to get onto something that's a little bit different. And these are my own personal thoughts. You can see an interview from my LinkedIn profile, hopefully, that I did recently with the Asian Banker, which is a network of 30,000 Asian financial institutions around something called a citizen trading data economy. And so if we're having this open file ICT infrastructure deployed across the edge, then data may never get to the cloud. Citizens' data may actually follow them around the edge of the network through an open fog ICT infrastructure. And so I think this is an opportunity for citizens to recapture ownership of their digital conversation, i.e. their IoT data. We know very well that IoT is going to be integrated within society. And so why not look at the opportunity for citizens to not only own their data, but leverage it as a trading currency? Maybe leveraging it for financial return. Maybe leveraging it for as a service. And this is important because we need to include citizens in the IoT revolution. This is happening. The IoT is coming to humanity. It's important that everybody's involved. So how do we do this? So what we could do is have an open fog trusted escrow account, a bit like you have your bank account, right, with all your money. Well, imagine there's a bank account with all your data. And that is stored in trusted escrow and in a secure IoT data vault. And that is held right at the edge of the network, where all your data is stored. And what we can do is work with financial institutions to participate in the Internet of Things revolution and offer citizens secure transactions leveraging things called blockchain and distributed ledger for automatic contract negotiation to trade their IoT data as a currency. Now, this is actually already happening, but it's a much higher level. And there's a great initiative called IoT Impact Labs in Massachusetts, run by a very good friend of mine, Chris Resendez. And they're actually storing fishing data in a data bank. New Bedford, which is in Massachusetts, is the largest fishing port in the United States of America. And all that fishing data, where they're going, what they're catching, all sorts of different types of climate information is being stored in one data bank. And access to that data requires some kind of financial reward. And you may well have heard of something called data lakes, kind of similar, but it's not as evolutionary. And I think we're going to start to see a lot more initiatives around this. And the European Union launched, literally about 2 months after I gave my keynote to the Asian Banker about this idea, launched an initiative around this exact concept. Can citizens' data be stored securely in their own data vault and be leveraged for a new type of currency, trading for as a service? So we're going to see a lot more of this. Okay, so let's go back to smart cities. There are multitudes of smart city initiatives around the world. And as you can see, there's a lot more than this actually, but this is kind of from the IEEE. I took it from the website a few months ago. But as you can see, there's a lot of smart city initiatives. And where you see the big red kind of orbs, those are mega cities. Those are with 10 million or more people. And you can see that it's not just about those, it's actually about smaller cities as well. And there's a lot more initiatives around the smaller cities. So that's fascinating. So, and there's lots of different smart city alliances. There's many different types of tiers of cities, and your approach to a smart city design will be very different for a tier 1 city, maybe 10 million or more people, than to a tier 5 city that has 100,000 residents or not. And so you need differing strategies, not only for the size of the city, but also for the territory, because developing economies might have a different approach to their ICT infrastructure than developed economies. Okay, and briefly, I wrote a white paper around this about how 4 mindful principles for building a smart city. This is a free download. It's been downloaded all over the world, and these best practices, these principles are being used in many, many different territories, and we're actually using these in Colorado. So some of the best practices we're starting to see in smart cities is that we're starting to see a lot more stakeholder collaboration. we start to see the public and the private sector come together in partnership, both recognizing that they have to work together to create a thriving social fabric. If things like congestion doesn't get resolved, then maybe a Fortune 500 company is going to have problems and get frustrated with their workforce not being able to get to work, and also for their clients struggling to get to meetings. And so everybody recognizes that we need to come together to resolve problems that affect everybody. Things like carbon reduction and air quality and clean technologies are very much a best practice in smart cities. Obviously, cyber, something called citywide data platforms. Now, Milton Keynes in the United States came up with this first, and that is this. Imagine that all your smart services that are operating on the ground assets, whether it be healthcare, transport, whatever it may be, that data, whatever ICT technology you're leveraging, is actually connecting at a data platform level. And at which point then you can start to see what's going on in each individual service and start using machine intelligence to actually look for improvements to each service because you've got more data. I hope that makes sense. Things like resilience, I've talked about. We are seeing a change in procurement and accountability. So, the IoT revolution has democratized innovation to a certain extent, which is fantastic. You can get hold of all sorts of different types of technologies and build out your own infrastructure, maybe using low-power wide area networks or Raspberry Pi or whatever it may be. But actually what we're starting to see now is the public sector write specifically IoT-specific things in the procurement process. So suppliers will be accountable to cybersecurity. They'll be accountable to the way that they actually manage and steward data and data privacy. And so procurement is changing from the public sector. And they're very much aware of IoT, very much aware of accountability for suppliers. And also citizens are being encouraged to get involved. And this is from Amsterdam. And basically, citizens are the stakeholders within any jurisdiction. And so it's important for citizens to have access to labs in order to participate in the innovation, to co-work together to resolve problems, maybe around transport, maybe around affordable housing, maybe around education, maybe around healthcare, maybe it could be anything. And don't forget that every city is unique. There's not one shoe to fit them all. So having a single supplier for a city is a bit of a troublesome thing to do. Having an ecosystem of suppliers gives you choice. And that's really quite important. And that's why the Smart City white paper around 4 principles to design a smart city is so popular. Okay, let's move on. So I want to talk to you about the Colorado Smart City Alliance. This is the first statewide alliance in the United States of America for smart cities. And you can see some information here, but basically it already covers 70% of Colorado's 5.5 million population. And there's many more cities and townships that are going to be joining the alliance. And that's really quite important. We have Arrow Electronics as the first private sector member that has joined the alliance. Colorado's biggest business association has joined. We've got the World Trade Center and NCAR that are global experts around climate change data. And also University of Colorado, because it's important that when we build smart cities, that the education curriculums are involved, and STEM is very, very important. We want as many people as possible to be educated in this digital economy, whether that be the guys that do business models to actually the people that do cybersecurity. And this is a global reaching alliance. So I just quickly want to play you a quick video and about the alliance, which I think that you will enjoy.
Humans have been living in cities for thousands of years. Only recently have we started living in high percentages in cities. In 2008, half of our population was living in urban environments. 70% of the world's population will live in cities by 2050. And that trend is only projected to increase over the next 20 or 30 years.
We're becoming a much more urbanized society. As cities grow, they need to be competitive. And how they're able to move people and goods around that city is key to that competitiveness. When we talk about smart cities, that's really what's at the heart of it. It's competitiveness, beautiful place to live, and how technology disappears into the background to make it easier to get around and enjoy life where you live.
With network infrastructure and computational analysis, we now have the ability to really listen to the built environment using sensors and actuators and data analytics and predictive analytics in a way that's not all that dissimilar to the way that we listen to the human body or to natural systems.
Being able to get real-time data off of the physical environment through technology so that we can make real-time dynamic decisions that make it easier for us to get around, make it easier to understand our environment, to give guidance to our population. It'll make things flow easily and seamlessly without us having to touch a button.
Colorado is the perfect microcosm in which to experiment and innovate in IoT and smart cities. And that's really the impetus for creating the Alliance. The Alliance represents cities up and down the Front Range and across the state of Colorado, and those organizations have agreed to come together to accelerate the adoption of smart cities technologies, policies, and practices.
No one entity can do it all on their own. It requires a collection of companies and enterprises, a public-private partnership. It's got to extend both into the business ecosystem and also into education in our universities.
Today, we're particularly proud to announce that Arrow, as part of their membership in the Colorado Smart Cities Alliance, is contributing to our effort in open data platform, essentially an innovation infrastructure on which our member cities can conduct pilots, and we believe that's going to greatly accelerate our efforts statewide.
Arrow's a global technology, design, engineering, integration and services company based here in Colorado.
What we're eager to work with Arrow on is really access to the subject matter expertise that exists within Arrow.
We've got access to over 800 technology companies. So for us to play a role in creating a vibrant community that's competitive, that has a forward plan to sustain the population growth, it's really important to the economic success of Arrow, to the employees we want to attract, and also how we want to put our partnership with Denver South and the Smart Cities Alliance on the global stage.
So hopefully you really enjoyed that presentation. But what we recognise is that if you resolve, for example, transport congestion in one city, pushes it out into the surrounding cities. So actually we're working also on a smart region strategy where we have a whole regional data platform and set of services to serve not just one city, but all the cities within a region. And we're going to see more and more of these kind of initiatives. So just briefly, I'm going to wrap up as soon as I can. There is money in smart cities. And the Mayor, Hancock, recently announced that a $2 billion mobility action plan for about 700,000 residents. And these are the targets he's looking at. He wants to reduce single car occupancy. He wants to increase the amount of walkers, cyclists, and leverage of public transport. And with another 3 million Colorado residents predicted by 2050, it's important that we do this right now because the stress will be too much on existing strategies, approaches for commuting. So things like transportation, mobility, affordable housing, and ensuring high quality of life for locales is something the form is looking at. And this is just south of Denver itself, contains a number of counties, number of cities, number of towns, is responsible for about $60 billion USD GDP each year, which is 20% of what Colorado generates